All right, if these examples appeared in the previous lesson, some of them, like the first one, we could have done, we just wouldn't have liked it. But the second one and the third one would have been really tough to do. But now with the fundamental theorem of calculus, it's a piece of cake. Here, let's just take a look. On this first one, we've got the definite integral from 1 to 2 of x squared minus 3 dx. Step number 1 is just to find the antiderivative of x squared plus 2. I'm going to get x cubed, I add 1 to the exponent, and then divide by that exponent. X cubed over 3 minus a 3x. Don't worry about your plus c. Now we're going to evaluate that from 1 to 2. Which one of those do you put in first? Put in the upper limit first. So I have 2 cubed divided by 3 minus 3 times 2 minus, and then I would suggest putting brackets around this so you don't have to remember to distribute the negative sign. We can do that separately. Now plug in 1. I would have 1 cubed, just 1, over 3, minus 3 times 1, 3. And now if this was on safe response question, of course that is a safe stop, but I think we can handle all of the arithmetic, and you definitely want to get the practice doing that. Don't let it be the arithmetic which, destroys you on the calculus exam. So 2 to the third is 8 over 3 minus a 6 minus, and then inside here I'll just distribute our negative sign, minus 1/3 and then plus 3. I did that because now I've got fractions I can combine and then whole numbers that I can combine. So 8/3 minus 1/3 gives us a 7/3, and then negative 6 plus 3 gives us a negative 3. Get a common denominator is going to be thirds, so 7/3 minus 9/3 gives us a negative 2/3. All right, so let's interpret our answer here. We just found the area underneath this parabola here from 1 to 2, and apparently most of that area is down below the x-axis because we got a negative answer when we were all done. So negative 2/3. All right, let's look at the next one. See how much easier that was? Oh, it's beautiful. And you're going, why didn't you just show me that to begin with? Why did I have to go through all that pain and torment? It's a rite of passage, and every calculus student has to make it. All right, so we have the definite integral from 1 to 4, 3 root x dx. 1 to 4, 3 root x dx. Okay, so I'm going to rewrite this one a little bit here. I'm going to pull out the 3 first of all. That's that constant multiple kind of property of definite integrals, 1 to 4, and rewrite that as x to the 1/2 power. We have to do the same kind of thing for derivatives, don't we? Of course we do. Bring down the 3. I'm going to have x to the, add 1 to that exponent. That would be 3/2. And whenever I divide by 3/2, it's like also multiplying by the reciprocal of that, which is times 2/3. Evaluated from 1 to 4. Okay, and then this 3 and this 3, those things are just going to cancel. Yep. Nice. And I just basically get 2 times, let's see, the square root of x cubed, and we're going to evaluate that from 1 to 4. All right, now as far as this goes, if you have to do this by hand, I'm going to suggest taking the square root first to make your number smaller, and then you can cube it up. So we've got 2 cube root, square root of 4, and then we can cube that, minus 2 times the square root of 1, which we will cube. The square root of 4 is 2. 2 cubed is 8. 8 times 2 gives us 16. The square root of 1 is 1. 1 cubed is 1 times 2 gives me 2, gives me a total of 14. Okay, so on this particular example, we're finding the area underneath the square root function from 1 to 4, and the majority, if not all of it, must have been up above the x-axis because we got a positive answer for our definite integral. One last one. We've got the definite integral from 0 to pi over 4 of secant squared. 0 pi over 4 secant squared x dx. What is the antiderivative of secant squared? Pretty sure it's tangent. How could we check our answer? All you got to do is take the derivative of tangent. The derivative of tangent is secant squared. And then we're going to evaluate that from 0 to pi over 4. So we want first the tangent of pi over 4. minus the tangent of, let's say tangent of 1. No, that's tangent of 0. Okay, so the tangent of pi over 4 should be easy. That's just 1. And then minus the tangent of 0 is 0, so we just get 1. So underneath the secant squared function, from 0 to pi over 4, you get a net area of 1.